So, you want to forecast the northern lights? It's not just about predicting some weird weather. We're talking about understanding a connection that stretches 150 million kilometers all the way from the sun right down to our atmosphere. It's truly one of the greatest shows in the entire solar system. And today, we're going to break down exactly how you can predict when it's about to happen.
Right, so a lot of people wonder, is the aurora just some kind of exotic, pretty weather? Like glowing clouds or maybe a weird polar fog? And hey, it's a fair question, but the answer is a whole lot more electrifying.
Nope, the aurora isn't weather at all. What you're actually seeing is part of a massive electrical circuit, a circuit that gets its power from the sun and ends up lighting our night sky.
The easiest way to think about it is like a giant neon sign. The sun, that's your power plant, pumping out all the energy. Earth's magnetic field acts like the wiring, the circuit that carries that power across space. And our atmosphere, well, that's the screen. It's the gas that glows when you flip the switch. Just keep that neon sign analogy in your head because it's the key to understanding everything else we're about to talk about.
Okay, so if the sun is our power plant, then our forecast obviously has to start there. And really, the sun has two main moods, two different ways it sends that energy our way that we need to keep an eye on. On one side, you've got what we call coronal holes. You can think of these as a steady, reliable drizzle of high-speed particles. They're predictable. But on the other side, you have coronal mass ejections, or CMEs. Now these are the solar hurricanes. We're talking violent, massive explosions that can trigger absolutely spectacular global auroras. Now, here's what's so cool about that steady drizzle from coronal holes. They're incredibly predictable. See, these holes are pretty stable features on the sun, and since the sun rotates about every 27 days, we can often predict aurora activity weeks in advance. If a coronal hole gives us a great show tonight, you can literally mark your calendar for 27 days from now. It's pretty amazing. CMEs are the complete opposite. They are the ultimate wild card. A single CME can blast billions of tons of plasma out into space, and the really fast ones can cross that entire 150 million kilometer gap to Earth in as little as 15 hours. These are the events that create those once-in-a-lifetime auroral storms that people talk about for years. So the sun throws all this energy at us, but Earth, we're not defenseless. We have this powerful magnetic shield. And the real secret to forecasting isn't just knowing a storm is on its way, it's knowing if that storm can actually get through our defenses. This shield, our magnetosphere, is incredibly good at its job. It deflects almost all of those solar wind particles, forcing them to flow around our planet like water around a boulder in a river. Which leads to the all-important question, if our shield is so strong, how does any of that storm energy actually get inside to power up the aurora? And here it is. This is the secret. The whole thing boils down to one single variable, the north-south direction of the magnetic field that the solar wind carries with it. Scientists call this the BZ component. If that BZ is pointing northward, it's aligned with Earth's fields and the door stays shut. But if that BZ flips and points southward, something incredible happens. The magnetic fields connect, they merge, and the door is thrown wide open, allowing a flood of energy to pour into our system. So remember this. A southward BZ is the master switch for the northern lights. And we can even put a number on it. If you ever see forecasters getting excited about BZ values hitting -10 nanoteslas, that's the magic number. That's the signal that the door is open and a major storm is probably getting started. Okay, so we've got the physics down. A solar storm needs that southward BZ to get in. Now let's look at how we actually read the real-time data to know when it's time to grab our coats and cameras and get outside. So the most common thing you'll see is called the K-index. It's a really simple scale from 0 to 9 that just gives you a general idea of how far south the aurora might be seen. A KP of 5 might bring it down to the northern US, while a big KP of 7 could mean people in places like Chicago get a show. But listen, here's a pro tip for you. KPL can lie. Seriously, it's a 3-hour global average, so it can completely miss a short, brilliant 30-minute flare-up happening right over your city. It's a decent guide, for sure, but for serious aurora hunting, you've got to look at the raw, real-time data. And where does that data come from? It comes from satellites parked 1.5 million kilometers away from Earth. The main one is called DSCOVR, and it sits at this special spot in space called L1, acting like our tripwire. It gets hit by the solar wind about 30 to 60 minutes before we do, giving us that crucial heads up. So let's watch the dashboard as a storm hits.
The very first thing we look for is our secret switch, B_Z, and there it is. It's plunging to -15. That is way past our magic number. The switch is on, the door is wide open. Next, we check the speed. And whoa, 750 kilometers per second. That's more than double the normal speed. The faster the wind, the more energy it just slams into our magnetic field. This thing is coming in hot.
And finally, we look at the density. 55 particles per cubic centimeter. A typical day is maybe 5, so this is more than 10 times the normal density. This isn't a gentle breeze. This is a shockwave, a hammer blow hitting our shield. You put those three things together, a strong southward breeze, crazy high speed, and massive density, and the result is a dead certainty. A major geomagnetic storm is on its way, and it's time to get ready. Now that we know the science and how to read the data, let's talk about how you can actually put this all to work and go on your own aurora hunt. There are a few key things to remember. First up, location, location, location. But forget your geographic latitude. The aurora is all about the magnetic pole, which is way up over northern Canada. And this gives folks in North America a huge advantage. It means someone in Minneapolis is actually at the same magnetic latitude as someone in Oslo, Norway, giving them a very similar shot at seeing the lights. Next, let's bust a common myth. So many people think a full moon will totally wash out the show. And yeah, it can hide a very faint aurora, but a strong display, it will easily outshine the moon, no problem. In fact, a little moonlight can be amazing for photos, lighting up the landscape and making your shot even more epic. So why is all of this so important right now? Because we are in what's called Solar Cycle 25, and it is blowing all the predictions out of the water. The official forecast was for a really weak cycle. But the reality? The sun is way more active than expected, giving us more sunspots, more CMEs, and more chances for aurora than we've seen in years. We are truly in a golden age for aurora hunting. So you see, the forecast is so much more than just a KP number. It's a story about a 150 million kilometer journey, a battle between a solar storm and Earth's shield, and that one secret key that opens the door. So now that you know the secret of that southern switch, the B, the only question left is, where will you go to watch the show?